Okay, so what is it that we're exactly going to do today? We are going to move into graphing. Let's graph some trig functions. What trig functions are we going to graph? The two basic ones, they are sine and cosine. Yep, that's it. So today is only sine and cosine, but I will ask you a few tangent questions, just so you know. Okay. All right. So in this first slide, these first couple slides, there's not much to do. Just kind of listen to it. Sound, temperature, ocean, tide, grandfather clocks. They all have something in common, and what it is they all repeat each other's answers. Okay. So, like for instance, when you just say sound waves go up, they go down, up and down, up and down, and sound waves they just repeat. They just repeat as they go. So does the ocean tide. So does the temperature. So you know in December it's going to be cold, but you know in June it's going to be warm. So it's going to go like this. Temperature goes like this. And this is what the graphs look like for sine and cosine. All of these have one thing in common. Their change is cyclical or periodic and can be modeled by, I can never say this. Thank you. Say it again. Sinusoidal? Curves. Sinusoidal. Okay. And if you do remember sine curves, guys, it's just like this. It goes like this. Okay. Are there other examples of this type of repetitive motion? This next slide just talks about how there's all kinds of repetitive graphs. Once you graph one thing, as soon as you end, it just repeats again, and then it repeats again and repeats again, and you know. This is basically your sine and cosine curve right here. You think of a heartbeat. I mean, there's all kinds of stuff going on, but it's pretty much repeating itself every whatever seconds. Okay? It doesn't what?
It doesn't. That's not a good thing.
It's not a very good thing, right? Okay, so here we go. This next slide is slide 3. See, we're already 3 slides in. See, it goes quick, so stay with me though. Okay. Changing the way we look at trig functions. Okay, on your XY chart or your axis, the y-axis doesn't change. So guys, everybody, just so you know, the y-axis is still going to be all real numbers, and everything stays the same. 1, 2, 3, and so on. Okay? Now, when it comes to the x-axis, things are going to change. Instead of using numbers like 1, 2, 3, 4, we're going to use theta. And theta is really measured in radians. And remember, radians, it's just a number. So it really does go by numbers. It's just kind of weird numbers when you look at it. For instance, I don't know if you can see this on your graph paper, but this is pi. This over here is 2 pi. And halfway between 0 radians and pi is what?
Pi over 2.
Half a pi. Halfway between pi and 2 pi is 3 halves pi. Okay, now just realize this.
Wouldn't it be? Oh, never mind.
Okay. Just realize this. These are still numbers. It's kind of weird though because every interval, like if you look at this interval right here, this is 1, 2, 3, 4 squares over, but 4 squares over stands for a number. What's the number?
Pi.
Yeah, but what's the number?
3.14.
Okay, so I just want you to understand, even though I put pi down, it's a number. Don't think of it as, oh, geez, now what's he doing? This number right here happens to be about 6.28 on the number line, right? From a couple days ago, do you remember what pi over 2 is? Roughly, what's pi over 2?
90.
It's like 1.557.
You're close. 1.57, roughly. So I just want you to understand, yes, they changed it to radians, but really radians are just numbers, and you're going by intervals that are strange intervals. But don't think of it as numbers, think of it as pi over 2, if I count by 90s, pi over 2, pi, 3 pi over 2, 2 pi, okay? Enough said on that, right? You get what I'm doing? Okay, next up. I want you to graph y equals sine of x. Now, x, I don't want x. I wish the book would do this, but they don't. Sine of what? Theta. But don't do it. Don't do it. Time out. Above that slide, do this. You ready? would you please make a circle and call it the unit circle? And if you call it the unit circle, the radius is what? 1. So we'll say it's the unit circle, radius 1. There's your triangle. This is x, this is y, which makes this point x, comma, y, correct? Okay. Now, if your radius is 1, tell me what this point is right here. How far out am I? 1, comma, 0. That's the point. What's this point? 0, comma, 1. Keep it going, guys. What's this one? Okay. And finally, okay, and this is going to be your big hitters. Now, when I say hitters, these are important points on the graph, okay? Now, so they're so important that I recommend right now, above your slide, you draw the circle and you write this down. I'm going to have you write down 1, 2, 3, times 4, 12 answers. Ready? The first thing I would like you to do is this. What is sine of 0 radians, cosine of 0 radians, and tangent of 0 radians? Okay? You need to, in about 6 days, no, sorry, 8, 9, 10 days. When you get to that test, this stuff is in your head. You don't even hardly have to think about it, okay? So guys, what is sine again? Sine is what over what? Look right here.
Y over.
Yep, y over r, but r is 1. So it's just y, isn't it? Do you get what I'm saying? So what is sine of theta? Sorry. What is sine of 0 radians? 0. Did you catch that? Sine is just what? The y value. That's all it is. Where cosine is just what?
X.
The x. So it's 1. Now, tangent, I just want you to do tangent just to keep it in your mind. Tangent is what over what?
0 over 1.
No, give me letters. Y over x. Remember, that triangle helps you determine what it is. So this is what? 0 over 1, which makes what? 0. So tangent at 0 radians is 0. Where cosine of 0 is 1 and sine of 0 is 0. Well, guess what? I want you to do it 9 more times. Here's the next one. This is what? Sine of pi over 2. Cosine of pi over 2. Tangent of pi over 2. So I want you to do it 3 more times up here. Get 3 more answers. Okay? And then again, do it for pi. And then again, do it for 3 pi over 2. Okay? Oh, I messed that up. Don't copy my work right now, guys. That's messed up. You can refer back to this anytime, but I hope in about a week you do not even have, you can just do this in your head so quick. Okay? By the way, this question was asked on the quiz yesterday. You had a tangent of, I think you had negative 270. You had this one. Negative 270 is right here. That was on the quiz yesterday. Okay, so what is sine of pi over 2?
1.
Guys, it's y over 1, so it's just y. It's 1, yep. How about this one? 0. Now, tangent is y over x, so it's going to be what?
1 over 0.
1 over 0, but 1 over 0
Undefined.
is undefined. You got it. Undefined. So, yes, tangent sometimes is undefined. And It happens actually twice around the circle. Okay? So what's sine of pi? It's y, it's 0. What's cosine of pi? Not 1. -1. Okay? And what's tangent to pi?
0.
Yeah, but tell me the ratio.
0 over 1.
0 over 1, which is 0. Okay, so these are your answers, right? Okay, now I'm down to 3 pi over 2. What? Oh, it's -1. You're right. But that's still 0, right?
Yeah.
Okay. All right. Sine of 3 pi over 2.
-1.
-1. Cosine.
0.
Tangent. Undefined because it's really this, right? Okay. Okay, there you go. Good. That is going to help you graph and graph and graph. I promise. If that's confusing, wow, you're going to have to really think hard about this stuff and stare at this stuff and make it make sense to you. Okay? So here we go. Nope. Back up. Oh, where am I at? Okay, right here. All right. So here's the deal. I want sine of theta to be graphed. I want 5 key points. And the 5 key points happen to be the ones I just did with you. So if you were lost and you didn't know what to do, you can always make a table, right guys? So in for theta goes what? And for y, what comes out? Well, we're going to put in these numbers that we just did. Let's put in 0 radians. Let's put in pi over 2 radians. Let's put in pi. Let's put in 3 pi over 2. And then let's get right back to where we started from. 2 pi is the same thing as 0 radians, right? Okay, if you're looking at that circle you just created, what is sine of 0?
0.
0. What is sine of pi over 2?
1.
And sine of pi?
0.
And sine of 3 pi over 2? And sine of 2 pi?
0.
Oh, guess what? I am right back to here. I am now starting to repeat myself. Do you get what I'm saying? So if I added one more angle on there, like what if I threw on,
That's 1.
it would be what?
1. 5 pi over 2.
5 pi over 2. 5 pi over 2 is the same as 90, so the answer would be 1. Okay, so that's what I mean by I'm starting to repeat myself once I hit 2 pi. Now, when you start to repeat yourself, you have completed a whole cycle. Or, to me, a whole cycle in a trig function is a period. Okay? All right, let's go graph them. So, looking at your graph, 0 went in, 0 came out. Right? Pi over 2 went in, what'd you get out? 1. Pi went in, 0 came out. 3 pi over 2 went in, -1 came out. 2 pi went in, 0. Okay. So just looking at this, the graph, I mean, to connect the points, would you go like this, 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 this?
Yes.
Yes? Kind of makes sense. You just follow the points, right? That's how you play. That's how you did dot to dot. Remember those? Dot to dot? Okay.
Wave.
It's a wave because here's the deal. If you guys did this, can you do sine of 30 in your head? What's sine of 30 degrees? Opposite of 30 is 1. Hypotenuse is what?
2.
So sine of 30 is 1 over
2.
So if this is 90, this is 45. 30's right here. And you just told me the answer is what?
1/2.
1/2. Oh, look. It's up there. So really, if you think about it, guys, it is not, it's not jagged. It is very what? What is it?
Wavy.
Rounded, yeah. Now, the second you get to the next 90, you're up to 1 again. You're right here. So this pattern continues forever. And if you go this way, at -90, you're where? You're at -1, right about there. Okay. Now, let me get rid of this. Okay, so this jagged curve, this jagged graph is not right, so don't do that. Okay, now, why are these called the key points? There must be a reason they call them the key points.
It is the maximum.
because of the, let's say again, Paul.
Got the maximum, the minimum, and the zero.
Okay, so yes, these key points find you the maximums, the minimums, and he says what?
Zero?
The zeros, which are the x-intercepts. He's right. You're getting the zeros. If you remember your Algebra 2 teacher last year, your Algebra 2 teacher probably said something like this. The graph starts where? At 0. Then goes where? Max, 0, min, 0, max, 0, min, and it just repeats. That's all it does. As long as you hit those key points. And those key points are 0, 90, 180, 270, 360, and that's all it is. Okay? Okay. Can I move on? Nod, nod. All right, 4 yes is good. All right, we will study the effects of A, B, C, D in the following function. Okay, so we're going to graph sine, and we have to look at these numbers. A, what does A do? B, C, and D. Also with cosine, we have to look at that too. Okay, so that's where we're going.
What? She keeps looking at me.
Okay, Will, look at me. Okay, here we go. First slide or next slide is this. Y equals 3 times. No, this isn't right.
Yeah, it is.
We didn't do cosine, did we?
No.
Okay, let's go back to cosine.
Cosine just starts at your max.
Yeah.
Where is it? Not there.
It's right after that.
How did I lose
You
it?
deleted it when you made a new page or something.
Gotta go find it.
Okay, so basically it's
Just erase the sign.
okay. Let's just go here. Cosine of theta
You just went by it.
equals y.
Yeah, you.
That was not it.
That's not it?
No.
There's a 3.
No.
The one that disappears one time. What is it?
It's just cosine.
Okay, that's it. Cosine of theta. Here we go. Well, guys, it is kind of the same thing, but you got to get your key points. So we're going to put what in for theta? 0.
Pi
Pi over 2.
Pi. 3 pi over 2. 2 pi. 5 pi over 2.
Okay. Now, again, at the top of your graph, you probably have the unit circle up there, so you can kind of see it, right? And you should know your 1, 0, 0, 1 and all this stuff. So cosine is just the x value. What's cosine of 0?
1.
1. Cosine of pi over 2?
0.
Cosine of pi.
Negative 1.
Cosine of 3 pi over 2. And cosine of 2 pi. Yeah.
1.
Okay. And you know what? The numbers didn't change, but the graph does change. It kind of looks like this. 0 radians. I think yours, does yours do this? Does it go by, quarter pi? Yeah?
Yes.
Okay. So quarter pi, half pi, and so forth. Okay. All right. Well, you know you got to go as high as 1. So here's 1, and here's negative 1. So at 0, you're going to be where? At 1. And at pi over 2, you're 0. Whoops, I missed it. Huh. Sorry. So let's try that again. Okay. And at pi, you're at what? Negative 1. At 3 pi over 2, 2 pi, 1. There it is. Good. So what's the big difference here? Where does cosine
Starts at
start?
Starts at maximum.
Yeah, cosine. Actually, the only difference between cosine and sine is where they start. Cosine starts at the what? Maximum. It'd be nice if you could remember that, but if you can't remember that, it's okay, because then you'll just do what? You'll just say, what's cosine of 0? Oh, it's 1. Oh, I start at the maximum. Okay? All right. Now is that right? Why is this not? Okay.
You will study the effects of A, B, C, and D. That's the next one.
Okay.
was the right one. Yep, that's where we went.
That one.
Alright.
We already did this, we already talked about this. Okay, so we're gonna look at all the effects. And the effects are gonna be this. Stretch it horizontally, stretch it vertically, move it right, left, up, down. Sometimes even reflect it. I don't think reflections are coming today, but they will. Okay? Okay, so here we go. Amplitude. Now there's something called amplitude. It's coming up right here. But the second you see cosine of x, you should think the parent. And you and I just graphed it, by the way. What does this 3 in front of the function mean? Don't say stretch.
Amplitude of 3.
Don't say that.
Multiply.
You don't say stretch. Now listen, when you say stretch, you say vertically or horizontally.
Maximum and minimum.
Vertically.
Not answer.
It's a vertical stretch, because it's in front, by what? By 3. Period. Okay? That's all it is. And that's all it's been all year. So if you guys could just quick sketch your parent and then stretch it by 3, you have it. So let's look at it. You know cosine starts at 1. Okay? 0 gets you 1. Pi over 2 gets you 0. Guys, I feel like there's just too much talking.
From right there.
Stop talking. Just listen. That's just being rude. Where's pi going to get you? Your minimum. Back to your 0. Back to your maximum. And you have this look right here. And that look is your parent. Is this cosine? Yeah, this is cosine of x, right? Okay, so this is cosine of theta, but you're not doing cosine of theta. You're doing 3 times cosine of theta. You know it's a vertical stretch. So if it's a vertical stretch, you're going to multiply what by 3? The y value. This point is 0, 1. So your 0, 1 goes to what?
0, 3.
0, 3. Where does this point go? 1/2 pi, comma, 0. It stays there. It can't get stretched because the y value is 0. And then this one goes where?
-3.
Okay. So really the maximums, the minimums, they stay the same, but the zeros, I said that wrong. The maximums, the minimums, they get stretched, but the zeros what? They don't go anywhere. Okay? So this doesn't go anywhere. This gets stretched 3 up. And here comes the graph now. Just like that. Okay, and it's going to repeat itself, okay? Now, this is called the amplitude, by the way, so the number in front of cosine sine is called the amplitude. So if I asked you on the homework or on a test, what's the amplitude? It's very simple. You look where? Look at the multiplier, it's right there. So if I did this to you, what's the amplitude? Which is it a stretch or a compression? Now instead of up 1, down 1, we're going up and down 3, 4. So it kind of got crunched together. It's a compression. Okay? All right. The A in y equals sine of theta, right here, the A, okay, represents a vertical stretch or a compression by a factor of A. We just did it. We had 3, didn't we? Okay. Now, I don't think you have this, so sorry. I wish you did, but I think it's covered up for you, isn't it?
No.
Oh, good, good, good. Okay, so it says here, A is the amplitude, is half the distance from the minimum point on the graph to the maximum point. So they just gave you a formula, and just so you know this, if the maximum is 3 and the minimum is -3, what's the distance? How far apart are they? 6. Now, to get the answer 6, you take the maximum number and you subtract the minimum number. So that distance, whatever that distance is, cut it in half, and that becomes your amplitude. So here, let me write you a formula. This is what they just told you. They just told you if you want the amplitude, you just take the maximum minus the minimum, whatever that is, that's the distance, and then you cut it in half. That's all you have to do. Okay, let's do it. Go back to the previous slide. What was the maximum number? Wasn't it 3? Minus the minimum. -3. Okay, and you know that says 1/2 times what? 6, which is 3. The amplitude is what? 3. And if you ever get a negative, amplitude is always what? It's always the absolute value of A, so it's always positive. So don't go, well, wait, my wave went down 3. No, it's not negative 3. It's always positive. You always say positive. Okay? All right, look at this one. This is a quick, would you please sketch that graph? From where to where? 0 to 2 pi. Just 0 to 2 pi sketch. Oh. If I was told to sketch it, I would just mark down the big 4 key points right there. Okay, get those down. By the way, I would just jot down my parent right away. So my parent is just sine of theta. Sine starts where?
0.
0. Okay, at the first key point, pi over 2, what is it? It is 1. The next key point. Next key point. Next key point. Okay, so here it is. Right? And of course it goes like this. Okay. Now what does the real function mean? What is this again?
Vertically compression.
By
1/2.
So all the y values get
Multiplied by 1/2.
cut in half. Okay, so this 1 is now what? Half. This negative 1 is negative half. How about the zeros? Stays the same. And there it goes. And there it goes. Okay, it was pretty quick, wasn't it? Yeah, so if you have a good understanding of your parent, it's not that bad. Okay, let's talk about the period again. The period is defined as the distance required to complete one cycle of the trig graph. Well, to complete the whole cycle, you have to go pretty much around the circle to get back to here. So the period is what?
2 pi.
Okay, so y equals sine of 2x is going to do something to your graph. When the number of 2 is in front of x inside,
Just horizontal stretch.
that's a horizontal, isn't it? Okay, and now, what'd you say, a horizontal what? Stretch. Everybody agree it's a stretch?
Yes.
No.
Well, it
Compression.
depends. Right now it's a stretch.
No, because 1 over
Opposite.
2.
Guys, if the number inside is bigger than 1, it seems like a stretch. It's not. It's a horizontal what? It's a compression. Okay? By what?
1 over 2.
By the reciprocal of 2, 1/2. Okay, so this one is kind of tricky because when the multiplier is the inside the grouping symbol, it's horizontally, and it's the opposite of what you think. Bigger than 1, it's a compression. And to be a compression, you'd have to multiply by 1/2, right? Okay, so here's what I would do, if I were you. Quick, do that. Get the parent on paper. Parent goes down. First, sine starts where? 0. At pi over 2, it's maxed out, then 0, then minimum, then 0, and you know now, I think, it goes like this.
Yes.
Okay, there it goes, and of course over here it goes like this, okay? But you don't have your parent, you have what? You have a horizontal compression. So all the x values get cut in half, okay? So if you cut these in half, this point right here is 0, 0. How do you cut a 0 in half? You don't? Okay, how do you cut that? That's pi over 2, right?
Pi over 4.
Comma 1. Yeah, what's half of the x?
Pi over 4.
Move it in. Look at the distance between the y-axis and the point. It got cut in half. This would get cut in half. It would be here. This would get cut in half. Since this is 6 squares out, it's going to be what? 3 squares out. It's like here. And this one is 8 squares out. It's going to be here.
So it's a
So what did it really do to your period?
2 pi to pi.
Cut it in half. Half of 2 pi is 1 pi. Now, this actually repeats again to here, to here, to here, to here. Oh, right there. So there's actually 2 periods. 2 periods in that one period of your parent, if that made sense. Okay, so this number controls your period. So if that number is 2, your normal period, 2 pi, gets cut in half. Are you listening? What if it was 4x or 4 theta?
We got fours.
You'd cut it in 4s. So guys, a 2 pi gets cut into 4 equal parts. Now your period is what?
Half a pi.
Yeah, it's 90 degrees. It's half pi. So what I'm trying to say is that number in front of x controls the period. Okay, so the next slide is all about the period. All right? So the period is known as what in your book? Letter what?
T.
T. Don't ask me why. It's just T. T equals, your period will always be 2 pi divided by what? B. Where do we get the B from? Right here. The B is the number in front of your theta or your x. All right? So if I was looking at this problem right here, cosine of 2x, and I just wanted to know what's the period on this one?
2 over.
I would say 2 pi divided by b, and b is what? 2. Here's the b right here. That's the b. The answer is what? 5. So you just cut your period right in half. Okay, but what if this was, let's just go like this, 9. What if it's cosine of 9 theta? Now what's the period? 2 pi divided by what? 9. That's the period. And by the way, 2 pi divided by 9, that's 360 divided by 9. It'd be like 40 degrees. In 40 degrees, this thing goes up, down, up. In 40 degrees, it goes really fast, like this. But anyways, just wanted you to see that. Would you mind if we don't graph that one? Because it's very similar to the last one. Yeah?
Oh, you wanna graph it?
I would love to.
Okay, we're not going to. All right, next up, phase shift. Phase shifts just basically mean horizontally move your parent around. Okay? Example: what transformation takes y equals sine of theta to what? To this. And I'm going to write it again because you can't see it very well. Theta minus pi over 4. What's going on here, guys? You're going to horizontally shift it where? To the right. How far? Pi over 4. There you go. Go do it. Go do that one. Get the parent down first, then shift it. Sine of theta, this is just the parent, it's on paper. So what are you going to do to all your points?
Move them right 1 box.
Right, 1 box, he says. Is he right? So pi, if you go pi over 4, isn't pi over 4 half of a 90? Yeah, so he's right. It's just, here's pi over 4. So the starting point 0, 0 goes to what? Pi over 4, comma 0. This point just moves over pi over 4. Well, I should do this in different colors, sorry. This point goes here, this point goes here. This point moves over 1, over 1, over 1, and over
Oh, it's up.
over 1. 1. And it goes like this, right? Up, down. Good? Don't look at that point, please. I messed up. On the other side, this also moves over 1, correct? There you go. Is that okay? This is your answer. Sine of what? Theta minus pi over 4. Okay? Good. Are you good?
Yeah.
All right. This is covered up, isn't it? A little bit. For sine of x, here I'm going to get rid of this. Where's my shade? There it is. For sine of x, the first point you graphed is at what? X equals what? 0. So here's what you guys did. You put in 0, and what'd you get? Sine of 0 is what? What is it? 0. Guys, when you put in sine of 0, you got 0. That's your first point, correct? Okay, so for y equals sine of b times x minus c. If you want to think of it this way, b times theta minus c. The first point will be when this number inside here happens to be 0. We want it to be 0, so we set it equal to 0. So when you see a big mess in there, all you do is this. You just go like that. You want to know where you start your graph? You start right here. Okay? So the starting x value will be this. Now hang on. How did they get that? They basically solved this, didn't they? Move the c over, divide by b. This becomes, whoa, I did that wrong. Hang on. This becomes the starting point. The starting point is c over what? B. So the x starting point is basically right here. C over B. Don't get what I just did? Here's what I'm saying. If I asked you to do this, sine of 2 theta minus 5. I'm just making something up here. Where exactly do you start this graph? Well, you want this to be sine of 0 in there, don't you? Because you guys all know what sine of 0 is. Sine of 0 is what? 0. But here's the deal. You got to know, how do I make that 0 in there? Well, you go like this.
5 halves.
Set it equal to 0. And basically, you get what?
5 halves.
Theta must be what?
5 over 2.
5 over 2. So that becomes your starting point. And that's a weird starting point, but that's what it becomes. I made that up, so that's why it's so weird. Do you want something that's not weird? What's not weird is what I just did with you. Remember when I did this one? Didn't I just do this with you?
Yeah.
Yeah? Well, guess what? If I set that equal to 0, what's the starting point?
Power 4.
Pi over 4. Is that where I started on that previous graph? Didn't I start at pi over 4?
Yeah.
That's what I'm trying to tell you. If you ever want your starting point, all you got to do, set it equal to 0. Hey, if you ever want the end point, the final point, now you just take the starting point and you add what? What's t? Add the period, right. So if you add the period, you will get the what?
Right.
Final point. So guys, now think back 2 slides ago. You guys started at what?
Power 4.
Pi over 4, and you got what? 0. Well, what's the final point going to be?
2.
Pi over 4 plus
2 pi.
the period, right? So the final point will be pi over 4 plus 2 pi. And by the way, I want you to get good at this quickly. 2 pi is really just, when we talk about force, 8 force pi. So what is the final point?
9/4 pi.
Yeah. It's 9 force pi, comma,
0.
0. You're repeating yourself right now. You're back to the beginning. Did you catch that? If you just want the final point, you just add the period on top of the starting point. Yeah? Okay. Now, listen closely. I'm giving you so much information. You're getting confused, I can tell. And here's the deal. Today, you're going to be at best average. Average to below average today. Tomorrow, you're going to be what?
Average
to above average. What do you get in day 3?
Above average.
Superior.
Above average,
You'll be really
super
good.
above average.
Okay. Vertical shifts. Do these graphs go up and down? Yes, they do. Look at this. This vertical shift is right here. You guys, you should know this one. What does A do? What is A?
Edge.
Vertical stretch or compression. This is what? Horizontal stretch or compression. This back here is a right or left movement. And the D value, what's the D value?
The vertical shift.
That's up and down. Okay? So all I'm going to say here is this. What does D do? It moves your graph up D units or what? Down D units. So when you see it, guys, it's the last thing you do. You take your parent, you go up 3, down 3. Okay? Okay. All right. This summary is terrible. You can't read it. Go 2 more slides forward. You got the same summary. Okay, see it? Yeah. That's a great place for you and I to start tomorrow. Okay. Now, here's the deal. In your assignment today, I would like you to skip this one. Skip this one. And then add this one. Okay? Skip, add. Alright? The other thing I need to tell you is this. You all need this graph paper. You have 4 to graph today. So graph all 4. I think it's starting with 37. The next 4. I also need your quizzes back, don't I? Yeah. Maddie has her quiz right here. Put your quiz in here, please. Before you leave. You guys just need 1 graph paper. 1. Yeah. Yeah, you can. Well, you don't need to. Oh, okay. I know, but in the book, we always get it. And I get what you read, but I want radians. So every book comes with a radian. It starts in radian and ends in radian. Okay.
Yeah. Oh, no, I didn't actually.
You have to graph 4 today, guys. 4.
Yeah, I got it.
Okay. Yes. Okay. Who did not get graph paper? Okay, that's it. Hey, I told you this. You'll be average today, at best. You're going to struggle on this. Some of this will be really hard for you. Okay? Tomorrow you'll get better. Quiz is right there, man.